Okay, we will do MCQ from exercise 4.3 and 4.4 as well. Okay, together, let's just do it together. The graph of ax plus by plus c equal to 0 is a straight line parallel to x-axis, or a straight line parallel to y-axis, or just a general straight line, or none of this. So this is just going to be a general straight line, because I've already told you a linear equation is always going to be a straight line. And since there's no zeros attached to x or y, it will not be any, we do not know if it's parallel to x-axis or y-axis. But in case, okay, in case, you have to listen very carefully to this part. In case the coefficient of x is 0, which means x in y, or no, because 0 and anything is 0 only. So you're getting something like this. So with no x, only y is there, right? So whenever this happens, y will be equal to something, at least in this case, okay? Or it can be numbers. I'm just writing alphabets right now, but most probably it will be numbers only. So when this happens, it means that the y-axis, on the y-axis, it's somewhere around here, whatever it is, the value, or negative y, so it's down here. So whatever it may be, y may be positive, right? Y may be negative, but if it's just y, then the graph will be something which is parallel to x-axis. Suppose y minus 2 that is equal to, if this minus 1 and this minus 2, right on minus 2, a line will appear parallel to x-axis. If y is 7, suppose, then right at 7, one line will be there parallel to x-axis. The same goes for when y is 0 and x is something. X has a value. X is 7, suppose. So x is 1, 2, 3, 4, 5, 6, 7. And right at 7, it will be a line parallel to y-axis. And then if x is minus 1, right at minus 1, there will be a line parallel to the y-axis. Got it? So that's it. Something, exercise 4.4 is all about that only. Nothing else is there. So that is that. The point of the form a minus 1 or minus a always lies on the line x equal to a, or y equal to minus a, or y equal to x, or x plus y equal to 0. So for this one, you just have to put the values instead of x. Suppose instead of x, because I've already told you this is going to be your x-axis, this is going to be your y-axis always. So instead of x, if I put a, y value to 998, it's not coming out anything. So this is also not rejected, because both x and y are there, right? They're saying y equal to x, but it's not equal because one is minus and one is plus. So this is the only option. Why? Because x plus y. So a, it's somewhat coming up like a plus minus a. So a minus a, look here, 0 is no, and they are saying it's 0. So this is the right option. Okay. Number 3, the equation of the line whose graph does not pass through the origin is, so origin is the point where the x-axis and y-axis pass through. So the point is usually 0, 0, where x is also 0, y is also 0. Okay. So they're saying the equation of the line whose graph do not pass through, that it's not passing through this. So if it is passing through the origin, then it should satisfy the equation when both x and y are 0. So x plus y equal to 0. If I put instead of x 0, y instead of y 0, of course it's getting 0. 0 plus 0 is 0 only. So this checks out the condition. We have to see which does not check out. Okay, so here also 0 minus 0 is 0 only. So this also checks out. This one, 0 plus 2 into 0. 2 zeros are 0. 0 plus 0 is 0. So this also checks out. This one, 0 minus 2 into 0 is also 0 only, but it says it's 1. So which means this do not pass through the origin. Because if it's passing through the origin, it's just not about origin. Okay, if suppose I show a line passing through 1, 1, x, y, is not. to 1 1 it is going to be. If I put a line point here 1 1 and then I give you a bunch of random equations and ask you which of this line passes through 1 1, you just have to put instead of x 1 instead of y 1, or it's just not even 1 1 also. You can even do minus 1 and 3. So minus 1 3, which points passes through the which equation passes through the point minus 1 3. It's the same technique which is the, it's just not about origin or a single point or like that. It can be any point. Okay, question number 4. If point this lies on the graph of the equation this, then the value of a. So as we have already told, I've already told you this x, this y. So instead of x, I'm going to put 3y equal to, instead of x, y, I'm going to put 1 by 3. So 3 into, instead of y, I'm going to put 1 by 3 equal to a into, instead of x, I'm going to put 3 minus 2. So 3 we can cut. Minus 2, if I send it this side, it will become plus 2. And then 3 into, I'll just keep it as 3 into a for the timing. And then 2 plus 1 is 3. 3, send it this side, it will become division. So a equal to 1, because you cut this, it will become 1. So a is 1. Got it? Next. That's number 5. And we have only till question number 7. After that, this chapter is over. And we will. But if you do have doubts from this chapter, do let me know. Okay. So let's try to solve it. The coordinate of the point where the line 3x minus 5 equal to this meets the x-axis. So when, suppose if a point is lying here, suppose 1 2 3 9 minus 1 minus 2, if a point is lying here, what is the name of the point? The name of the point will be what? 1 0, right? If a point is lying here, the name of this point will be 3 0. Similarly here it will be minus 2 0. And what you'll notice is that every time the value of y will always be 0 if it's lying on x-axis. If it's lying on y-axis, the value of x will always be 0. So they're saying the coordinate of point where the line this meets the x-axis. So if the line, that particular line passes through a point on x-axis, that particular point, at that particular point, the y will be 0 for sure, guaranteed, because it's lying on x-axis, just like any other point that's lying on x-axis. So 3x minus, this is the equation that they gave us. So instead of y, we can just put 0, right? And then 3x equal to 4 plus 0 is 4 only, minus 5 goes this side, it becomes plus 5. So x equal to 9 by 3 goes this side, plus division, so 3. So x is 3 and y will be 0 because it's on x-axis. So 3 0 is the point. Okay, next. The graph of y equal to 3 is a line. This I've already explained to you in the beginning. It will be line parallel to x-axis, right? Or there's 3 units. Okay, parallel to x, this is 3 units. Yeah, that's it. Done. And then question number 7. So like I've already told you, see, the thing is, if I say a point 1 1, now let's say, and I ask you how many straight lines can pass through this point, you'll say infinite. Literally, you can draw infinite number of straight lines passing through this particular point. But if I give you 2 points now, 1 1 and let's say 3 2, whatever it is, okay, and I ask you how many straight lines can pass through these 2 points, different straight lines, then you can say only 1, right? At least from one direction, only 1. So like for and when we make a linear equation, it's always going to be a straight line, right? So to know an equation is like to know the equation of a straight of a line, you have to see an equation which satisfies all 3 points. or at least 2 points. Minimum 2 points, but just to be sure you can do 3 points. Okay, otherwise minimum, since you're racing against time, just do 2 points. If it satisfies 2 points, you're done, because 2 points can make a straight line. So let's do the easiest one, 0, 3. So if I put 0 and 3, it will not come out 2, so this is no. If I put 0 and 3, it will come 6, not 3. Excuse me. Ay. Took by my member. See, y first is 0. Don't put 0 here, because x is 0, y is 3. So so one equation works for this, at least this one. Let's try this one in the same equation. So the other point also works. Just to be sure, I'm going to try the third point also. So 3 equal to 3. So this is the solution. Okay, that's how you make sure. Anyway, that's it for chapter 4 also.